Good morning, students. Today we are going to discuss one more problem on Lagrange's linear equation. So solve y plus z into p plus x, z plus x into q is equal to x plus y. So given equation I have written. So compare with the standard equation, capital P, capital Q, capital R, you are going to get auxiliary equations are dx by p, dy by q, dz by r. So I have written the p, q, r values. Now taking the multipliers, 1 triple 1 as one multiplier, 1 minus 1 0, 0 1 minus 1 as multipliers. So what happens? Multiply the numerator and denominator with 1 and add what you are going to dx plus dy plus dz by y plus z, z plus x, x plus y. Second one is 1 minus 1 0 and means dz term will vanish. Therefore dx minus dy by y plus z, this one you multiply with minus. You will get minus z minus x. Next one is 0 1 minus 1. First will vanish. Second one is dy minus dz by, so z plus x minus y. So from this one what we have to do is the, so dx plus dy plus dz by it is 2 times of x plus y plus z. Here it is y minus x, here it is z minus y. So integrating the last two, so dx minus dy by y minus x, dy minus dz by z minus y. So here dx minus dy, denominator is y minus x. Therefore write dy minus dx means you will get minus sign. Here z minus y. Therefore write dz minus dy. You will get one more minus sign. So both will be cancelled. Therefore it is f dash x by f of x mod log y minus x. Here log z minus y plus log c1. Therefore this if you move to the right left hand side, log a by b, log y minus x by z minus y is equal to log c1 or c2 whatever it may be, y minus x by z minus y is equal to c1. Similarly equate the first two, dx plus dy plus dz by dx minus dy by y minus x. So dx plus dy plus dz by 2 times of x plus y plus z is equal to minus dy minus dx by y minus x. Therefore this is nothing but 1 by 2 of this is f dash x by f of x mod log x plus y plus z, that is equal to minus of log y minus x plus log c1. So that implies log x plus y plus z is equal to 2, you move to the right hand side, minus 2 times of log y minus x plus log c1. Now you minus, you move to the left hand side, that means log a plus log b means log ab, log x plus y plus z into y minus x whole square is equal to log c1. Therefore both sides you remove the log. Therefore x plus y plus z into y minus x whole square is equal to c1. So next one more problem on the Lagrange's equation. X square minus yz into p plus y square minus zx into q is equal to z square minus xy. Therefore comparing with the standard equation, capital P, capital Q, capital R, you are going to get similarly dx by p, dy by q, dz by r. Taking 1 minus 1 0 as and 0 1 minus 1 as multipliers, you are going to get dx minus dy by x square minus yz minus y square minus zx. Similarly 0 1 minus 1 means dy minus dz by y square minus zx minus z square minus xy. Equating these two, what you are going to get dx minus dy by x square minus y square, z you take common, x minus y, dy minus dz by y square minus z square plus x into y minus z. Okay, so dx minus dy by x square minus y square can be written as x plus y into x minus y plus z into x minus y. dy minus dz by y plus z into y minus z plus x into y minus z. So now you take common x minus y is both the terms, x plus y plus z. Here y minus z you take common x plus y plus z. So these two will get cancelled. What happens? So f dash x by f of x model. Therefore log x minus y, here log y minus z plus log c1. That means log a minus log b, log x minus y by log y minus z is equal to log c1. Therefore x minus y by y minus z is equal to c1. Okay. So once c1 you got, next you require c2. So now you take x by z and 1 as multipliers. So x dx plus y dy plus z dz by x into this one p, y into q plus z into r is equal to triple one as multiplies dx plus dy plus dz by this one. So if we simplify, what we are going to get, this one is x cube plus y cube plus z cube minus 3xyz. Here x square plus y square plus z square minus xy minus yz minus zx. This you can write it as x plus y plus z into x square plus y square plus z square minus xy minus yz minus zx. Here the same. Therefore, these two will get cancelled. What you left with is x plus y plus z into dx plus dy plus dz. This one is x dx plus y dy plus z dz. So x plus y plus z into the differentiation of x plus y plus z. This is x dx plus y dy plus z dz. So integrating. So integral f of x into f dash of x into f of x model. F of x whole power n plus 1 by n plus 1. X plus y plus z whole square by 2. Here it is x square by 2 plus y square by 2 plus z square by 2 plus c2. So remaining to both sides, x plus y plus z whole square is equal to x square plus y square plus z square plus c2. So general solution is c1 comma c2 is equal to 0. c1 is this xy plus yz. So complete solution is what what you get, x minus y by y minus z, x minus y by y minus z. So c1 is this one. So you have to write this one. Okay, thank you.